Hey guys, Mr. McDonald here. Today in this video segment, we're going to talk about how we protect our central nervous system. Okay, we should start by talking about why it's important to protect our central nervous system. And we learned this way back in general biology when we talked about mitosis. And we learned that nerve cells go into something called the G0 phase of the cell cycle. And what that means is they don't reproduce. We learned about it again when we talked about the tissues in the histology chapter. And we learned that when nervous tissue has to be regenerated, it doesn't regenerate so well. And it's usually replaced by scar tissue or by dense fibrous connective tissue. And dense fibrous connective tissue doesn't have the ability to not generate impulses, but conduct electrical impulses that nerve tissue does. So we end up having problems because the tissue after the injury is different than the tissue before the injury. So our body goes to great lengths to try and protect our central nervous system. And again, our central nervous system consists of our brain and spinal cord. And today we're going to talk about those measures that the body takes. So what you see on this slide, guys, is a list of things that our body has to try and protect our brain and our spinal cord. The first thing that we start out with is our scalp and our skin. And our skin's kind of one of those things that we don't really think of as being protective, as being part of our immune system, even though it really is, because it prevents bacteria, viruses, fungi, all types of pathogens from just simply entering our body. All right, and we kind of overlook that. It also stops us from having abrasion injuries. Okay, having minor cuts. Okay, all those things are prevented by our scalp and our skin. So even though we cut our scalp or we cut our skin or we get an abrasion on our skin, we're not getting them on our brain or our spinal cord, which is really important. Okay, and then we go a step farther, and our body then encases our brain and our spinal cord in bone. And we've looked at vertebra. All right, we've learned all their names. We passed the juvenile moose vertebra around the room and looked at them. We've checked out the skull, and we see how in literally 360 degrees in 3D, our body tries to protect the central nervous system as best as it can. Okay, today we're going to get into three new things that you haven't heard about. That being the meninges, cerebrospinal fluid, and something called the blood-brain barrier. All right, so the next slide is a pretty important picture. Now there's a bunch of stuff on here. Let me get some markers here. Let's see, what color will we go with today? Let's go red. Okay, so there's some extra stuff on here that you guys don't need to worry about. You don't need to worry about this right now. You don't need to worry about that right now. You don't need to worry about that guy right now. That guy you don't need to worry about so much. All right. Guess maybe not that one. And we don't need to talk about blood vessels right now. So what is important though is these guys right there. That's a sweet circle, man. Couldn't do that better with a compass. Okay. So we start out with our most superficial protection, and that's our skin and our scalp, which is what we see right here. All right, so that's this layer right there. Okay, and then when we go deep to that, we get into the skeletal system. Okay, and that's these two guys right here, the periosteum, and then we have the skull. So here's our periosteum, which we learned about in our chapter on the skeletal system. It's a covering of bone. And then right here we have the actual skull, okay, which is there to provide a large degree of protection to blunt force trauma to our head. So those are the ones that we're familiar with. Okay, now when we go deep underneath that, we get into this layer, which collectively is called meninges. Okay, so our periosteal dura mater, our meningeal dura mater, our arachnoid mater, and our pia mater are all part of the meninges. Okay, so meninges is just a general term that would involve all of these folds and layers. Okay, now circulating within our meninges. Now again, we're talking about this space right here, and again also right up in here is where we would find our cerebrospinal fluid. Okay, and that kind of takes up the space. For lack of a better term, if you've ever ordered from Amazon, this is like the packing peanuts. It keeps our brain from sloshing around our head. It holds it in there firm and tight so that it doesn't hit our skull, because that can cause damage as well. All right, so again, going from deep to superficial this time, we have cerebrospinal fluid to protect our brain. Then the next most superficial layer are meninges. All right, pia mater, arachnoid mater, dura mater. Then we get to our skull and periosteum, and finally we get to our skin and our scalp. Okay, so again, those are the layers that we have naturally built up over our evolution as humans to protect the central nervous system. So we'll refer back to this picture again. So let's see here. Let's get rid of my marker. Done. Come back here. All right. So again, picking up with the meninges because the meninges are new. All right. So the outermost layer is called the dura mater, and the dura mater really has two parts. Okay, that's what we're getting into. Let's see. Let's get my marker back here again. Red today. All right. So the dura mater is the first outermost layer of the meninges. That's another awesome one I got going there. So the dura mater has two parts. The first one is called the periosteum. Okay, and the periosteum is attached to the inner layer, or the inner layer of our skull. Okay, so it lets the meninges attach to the skull, and it ties our brain into our skull, and it helps anchor it. Okay, and then we have this meningeal layer, which is the outer covering of the brain. So this is very much here our transition from skull to brain, and it's how we attach the two of them together. But we don't want them attached directly together, because that wouldn't give us any cushioning. Okay, so you have to understand that the whole point of all this is to provide a cushioning system for our brain. That's what we're trying to get out of this, a cushioning system. You know, it would be like eggs without an egg carton. The point of the egg carton is to cushion the eggs. So very much the cerebrospinal fluid and the meninges are the egg cartons. They're designed to protect the eggs. So that's what we have going on in here, and that's what we need to talk about. So let's move on to our next slide here. Okay, so then the middle layer is what's called the arachnoid layer. And it got that name because when scientists were first able to look at it using microscopy, because of its structure, they thought it looked like it had cobwebs in there. And that's why they called it the arachnoid layer. You know, there's not little arachnids. There's no like scorpions or spiders or anything running around in there, although it might be cooler if there were. But they saw these web-like things, you know, and that's what, oops, sorry, I didn't have it on marker. There we go. So those web-like things were what gave it the name arachnoid layer. And not to get into too much detail here, but there's this space in there called the subarachnoid space, and that's where we get cerebrospinal fluid. So again, the arachnoid villi get into reabsorbing it, and I don't get crazy into cerebrospinal fluid right now, but we find it here. And again, this arachnoid layer is the layer that's going to have the majority of the cerebrospinal fluid. And again, that's like the packing peanuts of our brain. And it keeps our brain from sloshing around inside our skull and damaging itself against our skull. All right. And then last but not least, we have the pia mater. And the pia mater is the most internal, most deep layer that clings to the surface of the brain. Had we been able to do our brain dissection, we would have all got to observe and feel pia mater, because it was still attached to our sheep brains. So These are, again, the layers that make up our meninges. So this side over here of this skull still has the meninges intact. All right, you can see the dormator because it's the most superficial. All right, but you can't see the deeper layers underneath that in this particular picture. And there you see our scalp above that, followed by our skin, which is our scalp is our skin. I'm sorry, our skull, and then our scalp. So this is just taken from a cadaver, and again, this is showing the unprotected brain on one side, which is pretty cool, the occipital lobe, and then we see the layers of protection on the other side. All right, so and again, I know some of you guys are into this stuff, and some of you guys will get to dissect a cadaver one day, and you guys will get to see this firsthand. And there's nothing like seeing it firsthand. It's a really, really cool thing to see, and you'll really appreciate, again, the lengths that our body goes to protect the central nervous system. All right, so a little bit about the cerebrospinal fluid. It's similar in composition to blood plasma. All right, it's formed by the cord plexus, which is a structure in the brain, and again, it's a watery cushion. It's like the packing peanuts. The point is to protect the brain, and we're not going to get into the complete circulation of cerebrospinal fluid, but it moves around in the arachnoid space around the brain. All right. If you've ever heard of a spinal tap, okay, not just the bad band from the 90s, but the actual spinal tap. It's a pretty painful procedure. It's common in cancer monitoring, where they stick a large gauge needle into your spine and withdraw fluid. They're getting the cerebrospinal fluid. And the point of that is to run different tests to see what type of enzymes and proteins, and if there's cancer cells in there. But that's something that's done as part of cancer monitoring. If you ever take the EMT course, because you want to work as a paramedic, one of the things that they teach you is to stick a napkin into someone's ear if you think that they've had head trauma. And the point is, if it comes out with a clear substance on it, that there's a good possibility that that's cerebrospinal fluid, and that person has a fractured skull. Okay, so those are things that you guys might come across depending what you guys end up doing, if you end up being lifeguards or anything like that. And again, that's places where you might come across cerebrospinal fluid in your everyday life outside of physiology class. Again, we're not going to get into how it moves through the brain and how it circulates. Okay, and that's what these slides are talking about. So before we get to the blood-brain barrier, which is a little bit different, I just want to revisit this picture again. All right, so again, so you understand what we have going on. We have the skin and the scalp that provides immediate external protection from blunt trauma. We have the periosteum and the skull, which again is going to do the same thing, immediate protection from blunt trauma. Now, when we get down underneath that, we're trying to protect the brain from bouncing back and forth and hitting the skull. Again, these are the packing peanuts from Amazon. So we get into meninges, the periosteal layer. All right, transitions and ties into the bone. All right, the meningeal layer down here is going to eventually tie into the brain. We have our arachnoid mater, which is a little bit deeper, which is where the cerebrospinal fluid circulates through. And then finally, we have the pia mater, which is going to attach directly to the brain. So what we've essentially done is we've provided a very hard, safe structure that can protect the brain from blunt force trauma. And now we're filling it up on the inside so that if we do get blunt force trauma, our brain doesn't slosh around in there. Okay, so let me move on here to the blood-brain barrier. All right, now the blood-brain barrier is a little bit different. Up until now, all the things that we checked out were about physical, again, blunt trauma. Think car accident. All right, you fell off your bike and hit your head. You got kicked with a soccer ball, okay, in a game. Those were those types of injuries. The blood-brain barrier is not a physical defense; it's a chemical defense, and the point of it is to protect your brain from chemicals that can hurt your brain. All right, so they're capillaries that aren't as permeable as other capillaries, and they try to exclude harmful substances. And really, it's easier to explain the blood-brain barrier instead of talking about what it protects us from, to talk about what it doesn't protect us from. Things that we're kind of familiar with. All right, alcohol can get past the blood-brain barrier. Nicotine can get past the blood-brain barrier. Caffeine can get past the blood-brain barrier. The blood-brain barrier. Say that 5 times fast. The blood-brain barrier. Anesthesia, okay, whether it's general or whether it is localized, can get past the blood-brain barrier. All right, so again, this is a chemical defense, all right, to try and keep these harmful chemicals away from our brain. And so that's kind of our last line of defense. So the first 4 that we talked about were all physical defenses, and this finally is a chemical defense. All right. And it's important for you guys to think about this, because some of the things that we talk about in class really relates to younger people, because they're the demographic that has to deal with these problems. Like when we talked about skin cancer, 18 to 24, bam, that's skin cancer in the U.S. All right. Damage to the brain, a lot of these things are happening to younger people. So let's check out a little bit of TBI, some traumatic brain injuries here. Concussions. You guys have all heard about concussions in the NFL, in soccer. High school soccer, I believe, has outlawed the header. You can't head a ball anymore. Concussions, I'm not even sure that they would print this slide anymore. It says is a slight brain injury with no permanent brain damage. That's not always necessarily true. There's a lot more research going into concussions. All right, so you guys are all painfully aware of concussions. Now, contusions, as they have here, is kind of the way it's described here, a step up from the concussion. Think about a pretty serious car accident. Okay, maybe someone getting in a fight and getting hit with a baseball bat or something like that. These are more serious. A concussion is just a minor contusion. It's a bruise to the brain. Okay, but the way it's described here, the contusion is more serious than a concussion. You get more tissue destruction. Okay, and again, as we talked about before, that tissue does not regenerate. So really, you can kind of lump those first 2 bullet points together. A concussion is just a lesser form of a contusion. All right, again, they're bruises on your brain, not something to kind of joke around with like we used to. When I sat in your chairs, concussions were not looked at as serious as they are today. Okay, and the last thing that we have up here is something that we've also talked about a little bit earlier, cerebral edema, and that ties in with meningitis. For those of you that are going to college or joining the military in the fall, you guys are going to have to get the meningitis vaccine if you haven't already. We've talked about vaccines. Vaccines are a big deal now with COVID-19. We talked about the non-vaccinating movement in class. But meningitis is really dangerous because it's an infection of the meninges. All right, and you can get that from bacteria, you can get that from fungus, you can get that from viruses. So there's a host of different ways you can come across meningitis, but your body's inflammatory response causes compression on the brain. Okay, and so when we get that swelling, it pushes in on our brain, and if it's too intense, it can lead to, in its most severe cases, death. They have to find a way to relieve that swelling. Even people who don't have that severe sometimes end up with hearing loss or other types of reoccurring problems. Okay, so again, that's meningitis, and again, you guys have to deal with that now. If you haven't already been vaccinated, those are required by a lot of colleges, and I'm pretty sure they are also required by the military. So we won't get into stroke right now, but that's what I want you guys to know about how we protect the central nervous system. And if you got any questions, let me know. Mr. McDonald out.